In today's question, a musician produces the sound of second harmonics from an open-end flute of 50 centimeter. The other person moves towards the musician with a speed of 10 km per hour from the second end of the room. If the speed of the sound is 330 meter per second, the frequency heard by the running person will be. So this question is, you can say, combination of your Doppler effect as well as the harmonics, or you can say wave. And so we are going to start with the wave part, which states that only the second harmonics is being heard by the man, okay? And that will be acting as a frequency, which is a actual frequency that is being heard by the person, and we are supposed to find out the apparent frequency which he is hearing. Okay. So this second harmonic is going to give us the actual frequency, and we are going to find out there from apparent frequency by using the Doppler effect. So let us first of all find out the actual frequency. So we start with the fundamental frequency of the flute. Fundamental frequency of flute, and we are given that it is a open-ended flute. So we can say for open-ended flute, lambda n, that is a wavelength for your nth harmonic, will be equal to 2L divided by n. And for second harmonic, the value of n will be equal to 2. For second harmonic, we have value of n is equal to 2. So we get this as lambda 2 will be equal to 2L divided by 2, which is equal to our 2 cancels out. So we get this as L, and length is given as 50 centimeter. So we can write this as 0.5 meters. So this is the, you can say, second harmonic wavelength. And from here we can find out the frequency of the second harmonic. So we can say frequency for second harmonic will be equal to velocity divided by wavelength, and velocity is our 330 divided by 0.5, and this comes as 660 hertz. So this is the actual frequency of the flute. You can say this is the actual frequency. And let us denote this by F, which will be equal to 660 hertz. Now we are going to use Doppler effect to find out the apparent frequency. Doppler effect. So we can write F prime will equal to F V plus V naught divided by V, as the observer is moving towards the source, and source is our flute. So we can write F prime is our apparent frequency or observed frequency. Observed frequency. And this F sometimes is also called as a natural frequency. Okay, so let me write here, F can be also called as a natural frequency. V is the velocity of the sound. which is given as 330, and V naught is the velocity of the observer. Velocity of observer. Now we simply substitute the value. We can get our f prime will be equal to 660, and here we have 330 plus, and the speed is given as our 10 km per hour, so we convert into meter per second. Okay. So let me write here, observer is given as 10 km per hour, so this comes as approximately as 2.78 meter per second. So we substitute it here, 2.78 and divide by 330, and this goes by 2, so we left with 2 multiplied by this will be approximately as 333, and which will be giving us 666 Hertz. So this is the apparent frequency which will be heard by the observer. And the options that are given to us, we can say option number A is the correct option. Option A is correct. So this question was a combination of both parts, Doppler effect as well as the wave part, harmonics part. So this completes the question. Thank you.